So DVPi stands for Damn Vulnerable Pi, and it's basically a penetration testing lab that you can install on a Raspberry Pi and use it to test your ethical hacking skills and tools without getting arrested, basically. And so it's available from this website here, and I'll put a link to this in the description. And I managed to hack it recently, and I just wanted to put this video together to show how I did that. So I'm no expert in this field by any means. I'm fairly new to ethical hacking, and I just put this video together for three reasons mainly. First is that I want to document what I've done, and it'll help me to crystallize what I've learned. Secondly, I tend to find that a lot of the YouTube videos you find on this sort of subject are pitched at a higher level than me, so there'll be a lot of assumed knowledge there, and you've got to try and understand some of that. And also there's a lot of videos where it's just a techno background and they don't explain much at all. So hopefully someone will come across this video and be in a similar position to me, and it might help them. But also it might be good if anyone who's better than me can see this video and maybe suggest ways that I could do this better and help with my own learning as well. So, like I say, this is installable on a Raspberry Pi, and this is the page where you can download and find instructions to install it. And there are two different images, and the one I'm going to be using here is the Sticky Fingers DVPi 3, and it says it's easy-ish in terms of difficulty level. There is a DVPi 2, which is medium, but I'm probably a way off being able to do that. I only just managed to do this one. So, yeah, I'm going to go through the steps I took to hack into this. So, basically, what we're looking for when we hack this is to capture two flags. Now let's find out where they are. So, there's a proof.txt file in the root directory, and then the root user has their own proof.txt file. So we will need to presumably elevate privileges to be able to get to this one. And what happens when you install it is you basically get this. It's a website front end when you set it all up. And I know without looking that that's a WordPress site, just because I'm very familiar with WordPress. But just to be sure, what I'm going to do is open up a Kali Linux, which is what I use to as my hacking platform. So one of the first things that people tend to do in this sort of thing is run NMap, which will tell us if there are any ports open. So this is what I did first. So NMap dvpi3.local. And that just scans it, and I can see that port 80 is open, which is what we're seeing it on here, and port 22, which is SSH. So there would potentially be options to try and attack that, presumably. But I'm going to go in through the website side of things. So I know that this is WordPress, but I can also run another tool called Nikto, and I can put the address in here. So it's Nikto and then H, and I'll just put the address in here. And what this will do is just scan the site for just basic statistics on what it uses and any potential vulnerabilities that you can use to attack it. So I'll just let that run. So this is finished now. It took a couple of minutes on my system, but I can see that we definitely have a WordPress installation here. And there are a few other things, but nothing that really jumped out at me at the time as something that I could use to exploit the system. So what I did next was you ran another tool called WPScan. I think if I type help here, I can show some of the options around WPScan. But what I know is one of the key vulnerabilities in WordPress is old plugins. Lots of people install plugins on WordPress installations to add extra features, and a lot of these sometimes are outdated and have vulnerabilities in them. So WPScan will I'll turn that around. WPScan will run a scan against plugins to see if there are any that could be exploited. So these are the options that I can use, and I think that the key one for me was this plugins detection, wherever it is. It's here, plugins detection mode, and what you do is you type that as the parameter, and you can say whether to do passive or aggressive, and I just used aggressive. So the command I actually used was WPScan -- and then the URL. So I put in and then this is where we have the parameters. So -- plugins detection aggressive. And this will take a while. So what I'll do is I'll pause the video again and show you the results when this has finished. So this scan is completed now, and if I scroll up, I'll be able to see all kinds of information about this WordPress installation. So there's a lot of information here, and the ones I'm really going to focus on are the ones here in red. They're the vulnerabilities. There are a few odd bits, like certain versions of themes are out of date, but any that are really vulnerable and potentially exploitable are highlighted here in red. And I can see that there's a version of this Akismet that's got a cross-site scripting vulnerability, and remote file inclusion could be used here as well. That's quite a bad one to have. Cross-site request forgery, there's quite a few here, but the one that I used, and it's probably the most dangerous here, I think, is this WP mobile detector, which has this arbitrary file upload vulnerability. And luckily in WPScan you get these links to find out more information about the exploit. So I'm just going to open one of these in a browser, so we can find some more details about this vulnerability from this website. And as we can see, it says it's a very easy one to exploit, and all the hacker needs to do is send a request to this resize.php. And that resize.php is found in WP content plugins, WP mobile detector, resize.php. And basically, as the source here, you just need to post a PHP file or which could be a web shell or a backdoor, and that can then be uploaded to the system. And what it does is it takes it without checking where it came from or what type of file it is, and stores it in WP mobile detector cache, and then your file will be here. So I'm going to do something similar here. I'm going to generate a PHP backdoor and upload it in a very similar way. So I'll just open up Kali Linux again. Now, Kali Linux has Apache installed within it, so you can serve PHP files from there or any type of web file. So the root directory of that is var www.html. And to test this, if I just go to 192.168.133, I can see the default page that you would see from a Apache server. You can check if Apache is running by going to service Apache to status, and that will just tell you if it's running or not. If it's not, you can do service Apache to start, and that will start it running. So I created a folder here called dvpi for me to create my script within. And now I'm in here. I'm going to create the PHP backdoor using Weevely by going to sudo Weevely generate. And what you do is you put in a password, and I just make something up, 1, 2, 3, 4, 5, 6, like that. And that just ensures that once your backdoor's on the server, only you can access it. And I'm just going to put in shell.php as the actual file. And we can see that it's generated shell.php. So if I go cat shell.php, we can see the contents of it. And basically, it's a very ugly looking PHP file, but it's deliberately so because it's trying to mask the code that's been uploaded here to avoid antiviruses and things like that. And so what we need to do now is get that onto this site here and get it uploaded using the exploit we found here. So if I go to /dv-pi/shell.php, I can see the actual payload here. Now, this might not be the best way of doing things here, but what I've had to do is make the PHP file actually display rather than be run. So ordinarily, if you had a PHP file on a web server, it would execute this in the background and you wouldn't actually see any code being outputted. But in order to get it to work in the way that's described here, I've had to get the code to show here. Now, there's probably a better way of doing this, but that's the only way I've found. And the way I've done this is to, within the dv-pi folder I've created there, I've created a htaccess file. And it's got two bits in here, PHP flag engine off and add type text plain PHP. And I think that essentially just stops PHP from running or executing any scripts within this folder. And it'll just render it all as text within the browser or wherever it's shown. So we can now use this as part of the exploit. And if I go back to this website here, what I'm going to do is copy this part of the URL that we have to post to. So we're going to this dv-pi3.local /WP content, plugins, WP mobile detector. And what we need to do is add a parameter and put source equals, and then I just need to copy in the shell address that I created here. And if I run that, we now get this weird dot, but I think that means that it's actually run and is working. We can just test that by going to the cache folder where this one should now be stored, and we can see that there's no 404s being thrown there, which presumably means that there's something running. So all being well, we've now got our web shell at this address on the server. And what we can do is use Weevely now, the same program we used to generate this PHP shell, to actually use it. So I'll just clear the screen here just to get rid of some of this. And what we would now do is, I tend to use sudo, I don't know if we need to, but if I put Weevely, then the address, so I've just copied and pasted that. So we've got our shell, which is on the dv-pi3 local, and then the password that I put in when I created the web shell, which was 1, 2, 3, 4, 5, 6. If I run this, it looks like we've now compromised the system. So if I go pwd to show the working directory, I can see we've now got our shell within this var www html wordpress wp content. And what Weevely allows you to do is navigate around like you're just using the command line of any Linux system. So I can go cd ... back one again, and now I'm in the root folder. I can see all of the WordPress files and directories. I could look at the contents of wp-config, for example, cat wp-config.php. I can see basically all of the keys here. I can see the database password, user, database name, anything I would need to compromise the WordPress site. So essentially, I could now do pretty much anything on this WordPress site. I could take it down, I could deface it, steal user credentials potentially, and one of the things I can do now is capture one of these flags. So if I go cd and go back to the root directory of the server, I can now press ls and I can see that we've got this proof.txt file, and I can go cat proof.txt and we can see it. So we've got this now as proof that we have now compromised the system. We can navigate around the server, go to the server's root directory and see that. So that's the first part of the exploit, and probably the easiest part. But once you've got there, you could actually do quite a lot of damage here if you were actually trying to compromise the system. The next flag is in the root folder, so the root users folder. And if I try to run cat on that one, we'll see that it says permission denied. So that means that we're going to have to escalate our privileges to be able to get to that, which is the next step of an exploit. And the way I did this, Weevely comes with lots of tools. So if I type help here, I can see them all. One of the first things you do generally is go something like system info, and that will just tell me about the system. I can see where the root of the website is. I can see what version of Linux it's running, the kernel version, and see if there's any exploits there. I did actually look at this to see if there were any, and I couldn't see any obvious ones. I tried a couple of ones that it said had privilege escalation, but they didn't work. But I can see, the PHP version and bits and pieces about that. You can also run who am I, and that'll tell you the user that you are currently. So I'm www.data, which is what tends to be for websites, but is actually quite a low-level privileged user. So we need to increase that somehow. There are a few other things here. So there's ways you can edit files, get other reverse TCP shells, things like that. So there's brute force SQL, ways you can dump databases and things like that. But I think the one I used and actually gave me the most clues was this audit file system. So if I run this now, what it does is it searches for writable files and anything that looks sort of suspicious. So it takes a little while to run, but what we can see is that we've got lots of writable files in certain folders, and some of these could potentially be run by the root user and therefore be exploitable. So the one, and this took me a long time to find, this isn't something that I found immediately. I spent ages trying to find this. It wasn't done in one session, put it that way. And eventually I found this one here, which is writable files in binary folders, and it's in this user local bin backup MySQL. And it caught my eye because MySQL is the database that it runs, and I figured that a root user might run this something called backup MySQL potentially, and that could potentially be a good place to target. So this is actually a folder. So if I go to cd user local bin backup MySQL, actually it's the one above it that's a folder. and show the contents of that. We've got this backup MySQL file, which we know is writable. And we've also got a couple of other ones, start MySQL and run MySQL. So let's just check that we can actually write into the backup.mysql file. So if I just open it first, I can see that we've got still working on it, want to give me a hand, backup not yet implemented, exit 0. So this looks to me like a file that someone's working on and has potentially left in there as something that could be used. But obviously, if you can write into this and the root user runs it, then you could potentially run some code to exploit the system or elevate your privileges, access files that you wouldn't normally be able to access. So the other file I looked at in here was this start MySQL. So if I just take a look at that one as well, I can see it's a script and you can pass in a status. So it actually explains this at the top. So you'd say usage start -MySQL, start, stop, status, and backup. Now the backup is what actually runs this script here, the writable script. So if I scroll down here, I can see that if I pass in as an argument backup, then it will run the script there and respond with a certain status. So let's just run that as an example here. If I go to start-MySQL backup, I can see backup not yet implemented, which is what the file actually would say. Yeah, it says echo backup not implemented. So that suggests to me that I can start to use that and put in my own commands. So what I did, and this might not be the best way of doing it, I just emptied that file by using cat backup. What is it? Backup-MySQL. So that's now empty if I look at it. I wrote into there just a file, a system command to see who the user is that's running it. So I put who am I, and I'm going to put that into backup MySQL. So if I look at it now, we can see that backup-MySQL now runs this who am I command, and what that would normally do is show who's actually logged in and running the script here. So let's run start MySQL and backup and see what happens. And as expected, it runs it and shows www data. Now this is all well and good, but the script seems to be running as me, the same level of user that I'm logged in as. In an ideal world, I would want that to say root, because I will want the root user to be running this file. So luckily, within this folder, there's also this run MySQL, which by the looks of things does very similar to start MySQL. And if I go to LSL, you can see that this is run by root and owned by root and staff. So potentially is one that we could use. It's got these, I think, the sudo permissions here. So I'm going to do exactly as I did with the start MySQL backup, but instead I'm going to use run. And we can now see that that is being run as root. And that's good because now we can put our own commands in here and anything we put in there will be run as root. So if I add another line to this backup-MySQL file, I can now get the contents of this root proof.text. So what I'm going to do is put echo and then the command I want it to run, and then I'm going to put that into backup-mysql. So if I cat backup-mysql, we've got the who am I command I put in earlier, but we've also made it run this cat root proof.text. So now if I run MySQL backup, that will run a who am I, and it should show the contents of this file here. And it does. So we've now seen the proof.txt file within the root directory, and that is the two files we've seen that both now, and we've proved that we've compromised the system. So that's it basically. We've done everything we need to do there, and we've used Weevely to do it. But there's one thing I haven't been able to do, and hopefully one day I'll be able to find out how, but it says there's an Easter egg within this, and there's a customer database with 10,000 email addresses and credit cards that you can use as an exciting climax to live hacking sessions. So I tried all sorts to get this, but I couldn't do it. So I used the WordPress's user to see if I could see if there were any databases there, and I couldn't see one. So I presume that you need to get root access to MySQL, but root MySQL had a password that I couldn't get at all. So I ended up giving up on that one. But yeah, that I would like to know how to get at some point. But I'll leave that one for now and just sort of take the win here with these two that I managed to get. So that's it for now. I hope you liked the video, and I'll speak to you later.